Good morning, everybody. This is Mr. Mack, or Mr. McWhorter if you prefer. I'm your biology teacher, and I was going to go ahead and do some of my first recorded and live lessons now that I'm getting adjusted into my new spot. You guys will have to forgive me. I got hired only last week, so I'm having to learn all this technology as fast as possible. But today's lesson is about identifying variables. And starting with this first experiment right here, this is about as simple as one can get. You can see here there's two pictures here. In one picture, the plant is different, or the picture is different here than it is here. I asked students, what is the most apparent thing that you can see that's different about this picture versus this one? Most students look and they see, oh, well, the thermometer is the same. They even see that the plant is the same. The pot is the same size. Even the color of whatever the potting soil looks like, it's the same. Light looks the same, except for this one seems to be on very bright. This one is barely on at all. So they can see then that there's light here and there's not one here. So the first question says, what is the student's change variable? The change variable is the same thing to you and me as something called the independent variable. Independent and change variable mean the same thing. I prefer the use of independent variable because that's what's going to be on the EOC exam. But you can think of them either way if that helps you. So, what do you think is the change variable? Whichever one you think it is, select that answer A, B, C, or D. And on this particular assignment, I asked students just to go to the bottom of the page, hit the enter key a couple of times, and it'll create a second page. You put the answers to number 1 and then fill in the answers to number 2, and when I grade it, I'll see your answers not here, but on the second page. All right? Then it says list all the control variables that you can see the student is keeping constant or the same. Remember, control variables and constants are the same thing. Constants equal the same thing as a control. So, some kids, I'll give you a hint, see that the temperature is the same. And I gave you a few other hints. The ones that you think are the same, go ahead and put those in for number 2 on the second page. Now let's take a look at this particular one here. This is another assignment you have called Identifying Variables Practice 1. In this one, it's a little more complicated. Remember, the change variable is the independent variable. And then here's something new that wasn't on the previous one, called the dependent variable. The dependent variable in this case, right, is the one that the students are measuring. And then finally, this last one here are the constants or controls. Now remember, controls and constants are the same thing. So what I want you to do is read these statements here. I want you to figure out which one that the student is actually changing. So let me help you with this first one. It says, it is January and Haley, Sarah, and Becky are tired of having cold feet while waiting for the school bus to come in the morning. They decide to design an experiment to test the effectiveness of wool, cotton, and nylon as insulators. Kind of like these would be socks, all right? Different kinds of socks. They fill identical bottles with, now notice that, identical, with 200 milliliters of water at 100 degrees Celsius. That's pretty hot. That's boiling temperature. And then place inside each sock, and then they take the temperature of the water after 20 minutes of time passes. So what in this particular experiment is being changed? Well, it kind of looks like, if you notice, that they're using different socks. The wool versus cotton versus nylon. That's changed. And it's the researcher who decides that. So you can imagine, you can put the material the sock is made of.
Mr. Mack, can I get a white?
Okay, next. It says the dependent variable. Remember, the dependent variable is also kind of like the responding variable. It responds to what kind of sock that you are using, or what you're doing with the independent variable. It's also the one that you're going to be measuring. If you look here, it says that they take the temperature of the water after 20 minutes of time. So you can imagine if they're going to measure the temperature, then that would be your dependent variable. So you can put temperature after 20 minutes. Or some people put the final temperature. Now, constants. These are things that they have to keep control of because, after all, they only want the temperature to change based on what kind of sock they have. They don't want it to change for other reasons. So it says here, let's look at some clues. It says they fill identical bottles. Well, if they're identical bottles, then that's a constant, so we'll put bottle. It looks like they used 200 milliliters of water for each one, so they kept the volume of water the same. They also started, or the initial temperature was the same. So same starting temperature of 100 degrees. That was the same. And they put that in each sock. And it also looks like, too, that they took the temperature after 20 minutes of time. So you could put then elapsed time. All right. This is an example of how to do one of these. On the next one, there's only one thing that's a little different. There's something called an experiment group and a control group. And the only reason that these are there are because these are human subjects. And so you can't just use one person for each group. You have to use like a whole group. That being the case then, the experimental group is just simply the one getting the independent variable. The control group is the one that isn't getting the independent variable. But the dependent variable is identified exactly the same way as it would have been up here in this one. Number 3 is very similar to number 2. Looking over on the opposite side, number 4 is a little more complicated than number 1, but it still works about the same way. In this case, just read it and you'll figure it out. Number 5, though, on the other hand, is quite a bit different. This works a lot like math. If you guys remember, the y-axis in math is usually called the dependent variable. Can you all see that? I'm going to scoot her up a little closer. On the other hand, the x-axis is the independent in math. Well, it works out that more often than not, we do it this same way in science. So you can take a look here and see that the temperature is on the x or horizontal axis. So that would be then the independent, or IV, independent variable. Here, on the other hand, light intensity is the one that's on the y, and it should then be the dependent variable. What we're saying here is the hotter an object is, the more intense the light that comes off of it. All right? All right, I hope this will help you to do these 2 assignments, and if you have questions, you can always email me or message me. I find that emailing is a little easier than using the focus messaging tool because the focus messaging tool doesn't tell me what class you're in. So when you're doing an email, can you at least tell me if you're a biology student versus an algebra student? And then that'll help me know how to better address your question. All right, I hope you guys have a great day and that you get some work done on Canvas today. All right, we miss you here at school though. Take care, everyone.